Hi, I'm Jonathan Whelan, the director of the First Tech Challenge program in Illinois and the creator of the Virtual Robot Simulator. Well, I did it with some students. We created the Virtual Robot Simulator during the COVID years in order to provide an alternative to in-person physical events. One thing we know is that schools can make coding fun. And they make coding fun by holding events at center stage. In 1989, Dean Kamen understood the value of hosting events at center stage, and he created the first robotics challenge. It started with 30 teams in 1989, and now it's up to over 300,000 students over the years. Now, there's a lot of software projects in this world that you can use to teach coding, but the VRS uses Dean Kamen's sports model to bring excitement to coding and bring excitement to kids. The key to the VRS project is to have the final event at center stage. What kid doesn't want to be at center stage to show off their work, and the parents love seeing their kids at center stage. Now, what are the probabilities of turning pro? I can guarantee you that everyone on that all-girls robotics team is going to turn pro, but a probability of a girls basketball player turning pro is 0.08%. So I want you to join me in helping Dean's homework. It won't be done until children everywhere have access to a first experience. We can reach the unreachable, those who don't have access to mentors, equipment, or tournaments, and we can do robotics in the virtual world. What does the virtual world look like? Well, we have the virtual world on the left and the regular world on the right, and you can see that these are nearly identical. The VRS and Firth both have the excitement of competition. Both are fun, collaborative, and every kid can participate. We have 4 games. This is Ultimate Goal, our teaching game, Freight Frenzy, Power Play, and of course this year's Center Stage. The VRS can be teacher-directed, self-paced, or flipped. We have embedded programming videos, a mini course, and lots of other resources. Teacher flipped, here's our embedded courses. So we have the robot arena, the programming window, and lesson challenges. So there's 3 ways to go through the project. This is what the final result would look like if you were an amazing programmer. Pushes the wobble goals up, shoots at the targets, and puts the goals in, moves the next wobble goal, and that's 123 points. So the Robot Arena is our multiplayer version, our programming version, and our lesson challenges. So this is what the multiplayer looks like. We have names, create the field. We have 4 robots. You can start the game. And you can see this is a tournament that we ran a year or 2 ago. 4 robots all independently working.
Some flashes on red. Red's taking a command and lead. They got a good rotation going. They're moving the wobble ball. They're looking for more rings to come out of the feeder. Red flashes are going wild. There's some blue.
So let's take a look at the lesson challenges. So we have drive forward, raise the flag. Each lesson challenge has a mini game, a video solution, and the code. So if you don't know the answer, you can just go right to the code. But let's take a look at the video solution. And of course, we have reset the field, initialize, play. We can download and upload programs. We can save programs. We can move the programs around by hitting these buttons. And let's take a look at the video solution. And there's the code. So this is an example of 5 activities that we can do. Drive to the white line, drive the white line with 4 motors, reverse, strafe to the right, strafe to the left, shoot rings in the tower. A little programming. So we can move the programming window around. We can change from Java to on-byte Java. So we have Java programming, we have blocks programming, but we'll stick with blocks for right now. So we can drive forward, and our motor power is either 0, 1, or 2, or between -1 and 1, and we have time. So we'll start here and see if we can get to the white line. Didn't quite get to the white line, so we can change this number to 2800. Excellent. Now we want to change our motors around. So we're going to come over here, we're going to go to DC motor, we're going to go to quad, and we need the 0 motor. You always want to stop the program from working. And of course, we want to turn the speed down since we have more motors. See what that one does. Reset the field. Went too far, so all right. Now let's say we want to make a right turn. And so we're going to take the motors, the quad motor. We'll always put a brake in here. We don't need it to be that long, so we'll just make this like 200. And we'll turn right. So we'll make this a -1. And make this a -1. Put a weight in there. Let's see what happens. Okay, so we turned. We just didn't turn a right turn. So we're going to save this as 4 motors, turn right. So we'll make this 400. So we'll try this with 400. Okay, a little overturn, so let's turn this back to 350. Maybe 300. Perfect. Now let's see what the color sections can do. So let's make this a little bit smaller. So we reverse the motors. We're using a variable here. This is going to be a strafing motor. We set more variables for colors. We're going to do red, green, or blue. And when red is greater than 100, it's going to stop. So let's go reset the field. Initialize, start. It's going to strafe to the right. Doesn't stop at blue. Stops at red. We could change that to go to the white. So now we're going to go forward. Put this back, make this a little smaller. And we'll go forward to the line and see what happens. Notice it didn't stop at the red line, so let's change this to a new color. Let's try blue. Stop the program, reset the field, initialize. So you can see how you can get a lot of iterations when you start the program. All right, so it's obviously over blue at the moment. So let's go to green. So we can put this greater than 61. So you can see how you can use color switches. So here's a little Java program to run the gamepad. Start. Okay, now let's learn some shooting. So let's take a look at this program. So we go forward. We've got to get that wobble goal out of the way. Then we're going to strafe to the right. And then we're going to spin up our motors and shoot. All right, and now we could also change the field view, camera setup. Let's go the other way and get the back view. No, we don't want that view. Here's the back view. I think this is a side view. The virtual robot simulator can run and plan your autonomous programs. So what you program in the VRS can be in your game. And this is from center stage. So watch the two programs run. Sorry, let's go back. Does it like that? These are all the different things that we can do with the robots. The resources available. These are our CAD our programs that you have access to. So the virtual robot goes to the park, and then the real robot goes to the park. So why should we play with robots? If you're females, they are develop their STEM interests, their engineering skills, their engineering interests. For students to have positive outcomes in the workforce. And it's not about the robots. It's never been about the robots. We're using kids to build robots. We're not using kids to build robots. We're using robots to build kids.